And you've seen some of these before, but here's our first one. And I'm cheating and looking at the book because I want to make sure that I use the same variables. This is not what I'm used to here. So they use A and P. This is very different from what I'm used to. And they use K. That's why K? I've never seen that before. All right. Well, this book was written by an Ohio State professor, so it must be something right about it. Hey, I got 2 degrees from the Ohio State University. I don't know. That's what they do. It's kind of annoying. I don't force it on people. All right. So this is called the compound interest formula. So the idea of compound interest is that when you put money in the bank and you earn interest, they add that money into your account, right? And then the next time you earn interest, you're earning interest on a larger amount because not just the money that you put in, but also the interest that they put in. And that interest keeps adding in. And so every time you earn interest, you're actually earning a little bit more because it's not just based on what you already had in there. It's the original amount plus all the interest that you've gotten. And the way this works out, it ends up being an exponential curve. And you can see the exponential piece of it. T would be like our X here. And just like any other exponential growth curve, the growth starts out kind of slow at the beginning, but the longer you leave it in there, the faster and faster it grows. The steepness of that line keeps getting bigger and bigger and bigger, which is why you want to start investing early so that when you're ready to retire, your money's growing like crazy. All right, so the way this works is we've got P, which is called our principal. I think it's PAL. That's our initial money. That's what we start off with. R is your rate as a decimal. So like 6% would be 0.06. K is your compounding interval. Actually, compounding frequency. That's what both of the K's are, yes. And this is relative to a year. So a lot of accounts are set up to compound monthly. If it's monthly, then K would equal, any guesses? 12. If it's quarterly, K would equal 4. If it's daily, 365. And then sometimes you'll see semi-annually, which in that case, K equals 2. Biannually, semi-annually, I think that those two things mean the same thing. Usually I hear semi-annual. I think about like TV commercials, like it's our semi-annual sale. And then T is your time in years. Okay, so let's practice writing an equation or two for a situation. I'll let you guys come up with a situation. Let's say high school graduation, you're dear Aunt Martha, who you haven't seen since you were 2 years old, lives out on the East Coast, a small fortune. You completely forgot about you, but she sends you a graduation card and there's a check in. How much is in the check? $8,000. All right. Thanks, Stefan. You want to make sure you send her a thank you card. So all the people who sent gifts, but $8,000. And we're gonna do something smart. We're gonna put it away for a little while. Now, are we ready to put it away for retirement, or do we have a closer goal? A car or buying a house? I like buying a house. Let's do buying a house. You want to have some, and we'll talk more about this on Friday, but you want to have a down payment when you buy a house, right? And it needs to be a decent chunk of money. The more down payment you have, the easier it is to buy your first house. So let's say so you're just graduated from high school. Let's say you're gonna go to college. You're probably not gonna buy a house right out of college. How long after you get out of college do you think you're gonna be looking to buy that first house? 6, 7 years. 28, 6 to 8 years after college. So we're looking at like 8 to 12 years after high school then for most people. I want to say like 10 years. Let's say 10 years. Say we're going to go 10 years. Yeah, let's say we invested and we can get an interest rate of, what do you guys think interest rates are like these days? I'm not the right person to ask. 6 would be pretty good. 6%, 6% would be pretty good. You can get more, and that depends on how you invest. Riskier investments will give a bigger yield, so bigger interest rate, but you never know. Like nothing's guaranteed when you invest in anything. So, but safer investments might give you something more like 6%. All right, and then let's go ahead and start with well, let's rate it a couple different ones. Okay, so let's go ahead and start with yearly. Let's say we're just earning yearly interest. So then our A would equal $8,000 times 1 plus our rate is 6%, but as a decimal, that is 0.06. 0.6 would be awesome. Woo! I wish. That's, yeah, like if you had a time machine and you could go back and invest in like Apple 20 years ago, you might get 60%. Over what? If yearly, then K is going to be yearly. That means you're only earning interest how many times a year? Once per year. So K would be 1. We're going yearly. And then that 1 appears up here also 1 times, and then however many years, which in this case is 10. So let's grab our calculators and figure out how much dear Aunt Martha's gift is going to be worth to us in 10 years. Anybody want to make any guesses? $10,000, you think? Oh, hey, that's all right. That's another $6,000 for just like putting in an account and letting it sit there. About 14,326.78. Now, do you think it's going to be better if we compound more frequently? Now, there's a trade-off here. Now, think about this. If we compound more frequently, we're getting a lot more interest payments, but the interest payment is going to be less, right? Because we're dividing by K here. So yes, if I go to semi-annually, this is going to end up being a 20 up here, but this is only going to be 0.06 divided by 2, isn't it? So you get more payments, you get twice as many payments, but you're only getting half as much interest each time. So there is a bit of a trade-off, but even with that trade-off, you think we're going to end up with more money or less? More? So let's go semi-annually. In which case K would equal 2. And then this equation would be exactly the same, except those ones are both going to turn into 2s. So it's 10 years, but now we're actually getting 20 payments. Our exponent is 20. And we had a vote for slightly more, we had a vote for slightly less. It is more? $100? I'd take it. Yeah, it's like $120. Yeah, I've seen this. So would you think that like we'd be better off if we compounded it even further? Like let's try it with K equals 12 instead. So monthly, we'd be doing monthly. And I'm going to write this out one more time. This time we're getting 120 payments over 10 years, but the interest rate is being divided by 12 also. So do you guys know that you can hit second enter on your calculator and bring back the last thing you typed in? Or you can just arrow up. But hey, there's another $100. So if you could choose between a bank that's going to give you quarterly interest or monthly interest, and the rate's going to be the same for both, which bank would you choose? Monthly, right? What if you could find a bank that would give you interest every day? Would you go with that? Every second. Let's do every second. All right. Let's do every second. How many seconds are there in a year? There's 60 in an hour, or 60 in a minute, times 60 in an hour, times 24 in a day, times 365. There's that many seconds in a year. I'm going to stow that into case so I don't have to type it in again. 8,000 times 1 plus 0.06 divided by, and I'm just going to use my stowed value of K. Hey, we got more money. 20 bucks more than if we did it monthly. So it turns out that banks, modern banks, don't do any of these things because there would be this constant competition to like one up the other person. Oh, you're going to do it every second. We'll give you interest every half second, right? And the thing is, it does grow the more frequently you compound, but there's a limit to it. There's an upper limit that you were talking about. And that upper limit is our second formula for today and our last one, actually. And I know you've seen this one. This is the PERT equation. You remember the PERT equation? There is such a thing as continuously compounding. So this would be And you'll learn about limits next year, but this will be the limit if k approached infinity. So like even more frequently than 1,000,000 times a second. And this is actually where the definition of E came from. In this case, it's A equals P times E to the RT. The PERT formula. This is the best we're ever going to do, even if we're compounding 20 trillion times per second. So for our particular situation, $8,000 times E to the, now this time the rate goes, R is the same as K, by the way. So R is our rate as a decimal. So this would still be 0.06. And then T is the number of years, just like it was a moment ago. And it's a little bit more than we just talked about. I wish I hadn't deleted that last one. Actually, I can get it back. Huh, that's interesting. It's actually less, isn't it? So it's less because of the seconds, and I'll tell you why that is. This is not accurate. I'd say this is not accurate because of this division here. Your calculator can only store a certain number of decimals. I'm taking 0.06 and dividing it by whatever K was. What is K? Yeah, 31 million. I'm taking 0.06 and dividing it by 31 million. That's going to be 0.0000 and a bunch of decimals, right? And it can only keep so many of those decimals, and a lot of them are zeros, so it had to round some stuff off. And I've already told you when you round in the middle of an exponential problem, it's going to give you issues. So the theoretical maximum that you could ever earn at 6% over 10 years, starting at $8,000, would be this time. All right. So that's about all I need to show you. How much time we got? Anybody know what time it is? You want to do one of the homework problems? Why not? We'll do number 9. It's a word problem. Your assignment is, I'll go ahead and write it down here. It's not on Canvas yet, so make sure you write this down. We're going to do one together, and then you're only going to have 7 left to do on your own. I'm sorry. Number 21 is about John. John's investing. Congratulations, John. You have $2,300. Your interest is, you found a winner, 9%. And it's quarterly. And this is a word problem, so we're going to have to write an equation and then we'll need to solve it. How long? Until John has, it's a very specific amount. John must be saving up for something very specific. $41,050. So the fact that it's quarterly here tells me we're not going to use the continuously compounding model. We're going to use the other one. We're going to need some initial amount. Initial amount, 23,000, 2,300. What's my rate as a decimal? Say 0.09. What's K if we're compounding quarterly? K would be 4. And then we need a 4 up here also. Times T, we don't know. That's what we don't know. We're going to solve for T. And our final amount at the end is going to be 41. I've said this before, I'll say it again, do not round in the middle of these problems. Okay? Use all those numbers and just leave them as fractions until you're ready to put in a final answer. So we're going to try and solve this thing. Always go for the low-hanging fruit first. What would be easy to do to this side over here? Let's divide on both sides by 2,300, right? And resist the urge to put that in your calculator and get a decimal answer and round it. Just leave it like it is. And some of you are going to be tempted to put 1 plus 0.09 over 4 into your calculator and get the decimal for that. We could do that. Actually, I think that's going to terminate, isn't it? Do you guys want to do that? It terminates. Why don't we, let's put this part into our calculator because I believe that will terminate. If it doesn't terminate, we don't want to put it in. We want to leave it, but I think this will work. You know what? I'm going to leave it alone. I'm going to leave it alone. Because if it ends up being 12, sometimes it doesn't terminate. So I'm going to do it as if we needed to leave it there. Okay, now I need to get this T out of my exponent. We've talked about different ways to do that. My personal favorite way to do it is to take a log on both sides. If I take a log on both sides, I'll be able to pull that 4T down front. Okay, so that's what I'm going to do. I'm going to take a log on both sides. I can do that. Yep. So if you want to simplify this fraction, remember your calculator will do that for you. You're welcome to do that. Math frac. Oh, that's super handy. And then because this is in a log now, we can pull that 4T down front. And this is going to get really messy to type in all at once, but I got this. 50, 2300. So I just need to divide by the 4 in the log and I'll have T by itself. Some of you aren't going to like having these big nasty fractions and stuff. I've dealt with way messier equations than this, so it doesn't bug me too much. You're going to end up dealing with way messier equations than this, so. Yeah, and then we just need to really carefully put that into our calculator and make sure, because there is more than one thing in my denominator here, I do need an extra set of parentheses around the entire denominator when you type it in. All right, folks, thank you. Bring your calculators and a pencil on Friday. That's all you're going to need on Friday. Calculator and a pencil. Leave your books at home, okay? No, we're going to do teach you more about money. The really important stuff about money.